Welcome back to The Explainer. So, have you ever had a research project just completely stall out before the interesting part even begins? Not because you lacked ideas, no, but because every single one of those ideas arrives with a massive, looming pile of setup work. We're talking about a small graveyard of ideas that looked absolutely perfect on paper, right up until they met reality. You know the drill. There are papers to find, code to set up, data to clean, experiments to configure, and results to meticulously document. For the longest time, access to knowledge was the main bottleneck. But now, well, the interface has totally changed. You can literally talk to a system and just ask it to organize your reading list. So today, we're zeroing in on a pivotal question. One scientist, many agents. Basically, can we use AI to handle that massive mountain of grunt work without actually losing our grip on the science itself?
Okay, let's dive into this. AI can absolutely make that pile of research work move faster. It's fantastic at generating more output. We're talking summaries, tables, and code at absolute lightning speed. But as we all know, faster is definitely not the same as better. The bottleneck in research hasn't disappeared, it's just fundamentally shifted. We've gone from finding information to deciding what actually deserves our trust. Does all this output actually give us more trust? The real question we're exploring today is whether AI can give a researcher more reach without giving away the human judgment that makes the research trustworthy in the first place.
To figure out how to safely achieve that reach, we first need to define what we actually mean by an agentic workflow. And to be clear, we are not talking about some fully autonomous, smooth-talking chatbot that acts as a replacement scientist. No way. An agentic workflow is a highly constrained, strictly bounded task. The system is given approved tools, explicitly defined rules for exactly when it must stop, and totally visible inputs and outputs. And honestly, the most critical part of this whole definition, the task is always handed back to a human being. Imagine a simple assignment for your AI assistant, not some broad, vague, hey, solve my whole research problem, but something much smaller and tightly defined. Step 1. The AI acts as a literature scout, searching an approved library for papers about one specific question. Step 2. It compares the methods used across those papers. Step 3. It actively flags contradictions. Maybe it puts a big red marker next to a result that completely contradicts the story you expected. The system can search, it can group, and it can point things out. It does all of this incredible heavy lifting. But then it stops. Period. And this isn't just a brief pause in the software. It's a hard, non-negotiable roadblock where the machine's job completely ends. This is the exact boundary where human decision-making absolutely must begin. The system does not decide what the evidence actually means. Which brings us to Section 2, the vocabulary of trust, distinguishing between outputs and facts. To use these tools effectively without ruining our integrity, we have to critically separate the AI's outputs into three very distinct tiers of trust. If we lose this distinction, we lose the research entirely. So the very first tier is what we call a candidate. A candidate is simply a generated summary or a suggested paper produced by your AI tool. Think of this merely as a lead, a hot tip, if you will. It hasn't been verified yet. The AI is essentially just tapping you on the shoulder and saying, hey, look over here. This might be relevant. But it is absolutely not yet a fact you can rely on. It's just a possibility. Now, that candidate only graduates to our second tier, evidence, once a human being actually opens the original primary source. You, the researcher, have to check what was actually tested, under what exact conditions, against which baseline, was that apparent contradiction even real? It only becomes evidence because you have verified the result with your own eyes and recorded exactly why that source was accepted, rejected, or left uncertain. Finally, we reach the absolute highest tier, a claim. A claim requires total, unapologetic human ownership. It is a verified statement that you are fully prepared to defend to a highly skeptical colleague. I want you to imagine a really simple test. If your AI tool completely vanished tomorrow, just poof, gone, could you still explain why that specific method was chosen? Could you reproduce the analysis yourself? Could you defend the conclusion? If the answer is yes, you have a claim. If not, you do not have a defensible contribution. Which brings us to a very real, very seductive danger. Section 3, the fluent illusion trap, when speed creates false understanding. Now, what's really interesting about this is how speed creates a trap in research. When an AI system hands you a highly coherent, beautifully formatted answer, complete with neat tables and code that runs perfectly, it is incredibly tempting to believe you automatically understand the result. Let's deconstruct a mock comparison table, for example. At first glance, it looks fantastic. 10 papers, 3 methods, a confident, clean conclusion.
It looks perfectly organized and completely plausible. But if you look closer at the hidden flaws in the rows, the illusion breaks. One citation is completely wrong. Two of these papers were never actually opened or read by the system. It just hallucinated them from the metadata. And that apparent consensus it so proudly displays, it actually comes from AI summaries that just blindly repeated the exact same flawed assumption over and over.
So here is the harsh reality we have to face. Useful output does not equal a defensible contribution. That table might be a highly useful output to get you started on your reading journey, sure, but outsourcing your understanding means it is absolutely not a defensible literature review. If you haven't done the checking yourself, you just have a beautifully formatted illusion of knowledge. To prevent that kind of catastrophic failure, we need a strict operational rule. Section 4, the Human Accountability Gate, the operational verification practice. This is where we firmly establish the human researcher as the ultimate gatekeeper of truth. We can't just cross our fingers and hope we catch these fluent errors. We need a systematic practice embedded right into the workflow. For every single statement that materially shapes your research question, you must open the primary source and manually record 4 very specific things. 1, what it actually tested. 2, the precise conditions of the test. 3, the limitation of the study. And 4, exactly why it matters to your specific case. If a source cannot survive this rigorous 4-step check, it gets kicked right back down the ladder. It remains just a candidate, a lead for sure, but definitely not evidence. So the crucial point is this. AI can generate candidates, but the researcher owns the claim. The human stop points in this workflow are not just decorative little disclaimers tacked on at the end to make us feel better. They are the core method itself. A truly useful research assistant doesn't just feed you smooth, easy answers. It makes its own uncertainty highly legible. It should clearly distinguish a source it actually opened from one it only saw in the metadata. It should leave a highly visible gap when the evidence is incomplete, rather than just paving over that gap with a fluent, convincing paragraph. This shifts your entire mindset. Instead of asking the AI, hey, what's the answer? You start asking, which part of this map is the least reliable and what do I need to inspect next? The very first place you should test this dynamic out is in your literature review. Because, let's be real, a faster research process is totally useless if it misses the one key paper that changes your entire project. Which leaves us with this final critical thought to chew on. Your literature review has a blind spot. Can AI help find it without pretending the blind spot has disappeared? We will explore exactly how to map out those field blind spots in our next explainer. Thanks so much for learning with me today.